Hello everyone, my name is Risha and today we will be discussing about clock domain crossing. Before I talk to you about clock domain crossing in depth, here's a small skit prepared by students of RVC belonging to VLSI branch 2123. See you at the end of the video.
Hey guys, let's have a peaceful session of meditation. We are really stressed out.
But I don't know how to meditate.
Don't worry, I'll teach you.
Okay, let's go.
Let's go. Welcome to today's meditation session. Let's start by setting some intentions. What would you like to cultivate today?
Well, I would like to cultivate a deeper understanding of clock domain crossing.
Same here. It's been giving me a headache.
Cross domain crossing, is that like a rush hour traffic?
Sort of, it's when signal cross between different clock domains and cause a timing issue.
Okay, it's an nightmare for analog designers too.
Digital designers too. We need to synchronize the clocks properly to avoid glitches.
I don't know much about the clock, but I do know about the traffic. Maybe I can relate it to it.
I don't know anything about this. I'm just a intern.
It's okay, Sandeep. We all start from somewhere. Let's all close our eyes and start a meditation.
What was that? Sounds like a traffic jam.
Oh no, we are experiencing a clock domain crossing.
Just what we needed during meditation.
I thought this is supposed to be a peaceful place.
Hey, looks like our signals need some traffic control.
Maybe we need a roundabout for our clock signals. I don't get it.
Don't worry, Sandeep. We are using traffic as a metaphor for CDC. Like, we need to manage traffic to avoid accidents. We need to manage signal as well to avoid timing issues.
We need to synchronize our signals properly and add appropriate delays if needed.
And make sure that our clock domains are isolated and do not interact with each other.
We need to plan ahead for any potential timing issues and address them in the design cycle.
And verify our design thoroughly to catch any timing violations.
With that, our analog signals are stable and are not affected by digital noise.
Also, the digital signal should be made clean and it should not have any interference by the analog ones.
Hope our customers don't experience any delay in their products. I believe I don't cause any timing violation.
Welcome back everyone. Hope you liked the video. Without wasting any further time, let me take you through an example and explain your CDC a bit further. Consider this diagram. We have two flops both operating at different clock domain frequencies. Now, the output from A is fed into the input of flip-flop B. Since B is operating at a different clock frequency, as seen in the waveform, we can see that B is trying to capture the data A at the same time that data is changing. It's going into the negative end. So what this means is we are clearly in violation of setup time. So this will definitely lead to metastability condition and all the other problems that you can think of. To avoid this, the solution is to add a synchronizer, that is a flip-flop itself, before it is latched and passed out from the flip-flop B domain, which will look something like this. Now, this is a simple circuit where input has nothing to do with it. We are directly driving the input from the output of the flop A to the input of the flop B, and we have added the synchronizer now. But does this take care of all the CDC issues? In fact, no. CDC issue is a use case based scenario and it has to be dealt with in accordance with the problem that you see. So the idea is to calculate metastability in a circuit, find out its MTBF. You can learn more about MTBF metastability conditions from the book referenced in the beginning of the video. And I would actually recommend that you go through metastability before coming and watching this video on CDC. So coming back now, say for example, take this circuit. Here, from the output from A is passed through a combination circuit before it is passed on to the clock domain B flip-flops. What happens in this condition is due to the addition of combinational circuits, there is a chance of other timing violations taking place. We may again encounter setup hold violations. Avoid this, it is always favorable that the input is registered and then passed on to a different clock domain. The solution for this in terms of circuitry is this. Hope you understood what CDC means. I know this was a rather short video, but for more in-depth knowledge and use case scenario, as I mentioned earlier, please go through the book mentioned in the reference section at the beginning of the video by R.J. Gauri Ganesh. And yeah, till then, have a nice one and thank you.